Welcome, space travelers. Tonight, we're going to drift through a quieter kind of cosmic strangeness. Not fantasy, not science fiction, not rumors from the edge of the internet, but real facts about space that sound almost too strange to be true. Things like planets without stars, moons with methane rain, stars that can be listened to, black holes we have actually photographed, ancient light still glowing around us, and a universe where most of the matter is invisible. These are the kinds of facts that feel impossible at first, but the deeper you go, the more you realize they are not impossible at all. They are simply space behaving the way space behaves when it is not trying to match human intuition. So get comfortable. Let your body rest, let the room become still, and let your mind travel slowly. Tonight's journey is built to be calm, but not empty. We'll move from one strange true fact to the next, gently, without rushing. Some facts will take us to distant planets. Some will bring us back to our own moon. Some will move through black holes, neutron stars, dark matter, old light, and the hidden structures of the universe. And through it all, the feeling should be the same: quiet wonder. Because sometimes the most relaxing thing about astronomy is realizing that the universe is far stranger than anything we would have invented, and yet it is real. 1. There are more than 6,000 confirmed planets outside our solar system. That number sounds like something from a futuristic civilization, but it is already true. These worlds are called exoplanets, and they orbit other stars, while some drift freely without any star at all. For most of human history, we only knew the planets of our own solar system, and even the idea of planets around other stars was something people could only guess at. Now we know the galaxy is full of them: rocky worlds, gas giants, lava planets, ocean candidates, star-hugging planets, and frozen wanderers. The 6,000 confirmed exoplanets are not the whole collection. They are only the ones we have managed to detect so far. 2. Some planets do not orbit any star. They are called rogue planets, and they drift through the galaxy alone, untethered to a sun. That sounds lonely and almost poetic, like a world exiled into darkness, but it is a real category of object. Some rogue planets may have formed around stars and then been thrown out by gravitational chaos. Others may have formed more like tiny failed stars from collapsing clouds of gas and dust. Without a nearby star, they would be dark, invisible light, difficult to find, and incredibly cold unless they hold internal heat. They may wander for billions of years, moving silently through the Milky Way with no sunrise and no sunset. 3. A planet can have two suns. Kepler 16b is a real-world orbiting two stars, sometimes described as the closest real-life version of a Tatooine-like planet. It is not thought to be habitable, and it is not a dry desert world with people staring at twin sunsets. It is a cold, gaseous world. But the basic idea is real. A planet can circle a binary star system where two stars orbit each other, and the planet orbits both. For a long time, people wondered whether planets could survive in systems with such complicated gravity. Kepler 16b showed that they can. The universe does not require simple skies. 4. There is a blue planet where the weather may include glass blown sideways. HD 189733b is a gas giant that looks beautiful from far away, with a deep blue color that might remind you of Earth. But the resemblance stops there. Its blue color is connected to a hot, hazy atmosphere with clouds thought to be laced with glass-like silicate particles, and NASA describes winds that can send that storming glass sideways at thousands of miles per hour. It is one of the best examples of a cosmic trick, a world that looks calm and oceanic, but is actually a nightmare of heat, pressure, and violent atmospheric chemistry. 5. There is a planet covered in a global ocean of lava. 55 Cancri A is a super-Earth, nearly twice Earth's radius and about 8 times Earth's mass. But it is not an improved version of Earth. It orbits so close to its star that its year lasts less than one Earth day. NASA describes it as a super-hot world covered in a global lava ocean with sparkling skies. That sounds like fantasy, but rocky planets close to their stars can become so intensely heated that their surfaces melt. It is a reminder that rocky planet does not always mean gentle mountains and oceans. Sometimes it means a glowing sea of molten stone. 6. Some planets have years shorter than a day on Earth. On Earth, a year feels long because our planet takes about 365 days to orbit the Sun. But a planet very close to its star can complete an orbit in only a few days, or even less than one day. 55. Cancri E takes about 0.7 Earth days to circle its star. That means by the time a person on Earth has breakfast, lunch, and dinner, an entire alien year could have passed on that world. The word year is not universal. It simply means one orbit. Somewhere else, a year can be shorter than a night. 7. The universe is mostly made of things we cannot see. Ordinary matter, the stuff that makes stars, planets, oceans, trees, telescopes, and our own bodies, makes up only about 5% of the universe. Dark matter makes up about 27%, and dark energy makes up about 68%. That means almost everything in the cosmos is not the ordinary, visible material we interact with every day. This is one of those facts that sounds like a philosophical joke, but it is part of modern cosmology. The visible universe is not the main substance of reality. It is more like a bright foam on top of a much deeper, invisible sea. 8. Dark matter does not glow, reflect, or absorb light, but it helps shape galaxies. Scientists cannot see dark matter directly with ordinary telescopes because it does not seem to interact with the electromagnetic spectrum the way normal matter does. It does not shine like a star. It does not reflect light like a planet. It does not block light like dust in the normal way. But it has gravity, and that gravity affects the motions of galaxies and galaxy clusters. In a strange sense, dark matter is known through its influence. It is the invisible architecture of the cosmos, shaping visible structures from behind the curtain. 9. The universe still glows with ancient light from its early childhood. This light is called the cosmic microwave background. It was released when the universe became transparent about 380,000 years after the Big Bang. Before then, the cosmos was like a hot fog where light could not travel freely for long. Then atoms formed, the fog cleared, and light began crossing space. Today, that light has been stretched by cosmic expansion into a cold microwave glow of about 2.7 Kelvin. It is not visible to your eyes, but it is everywhere. Even in a dark room, even between galaxies, the oldest light we can observe is still quietly present. 10. The darkness of space is not truly empty. Even when you move far from stars, planets, dust, and galaxies, space still contains fields, radiation, stray particles, and the faint glow of the cosmic microwave background. Empty space is not a simple nothing. It has structure, history, and physical behavior. The vacuum of space can stretch. It can carry gravitational waves. It can be shaped by quantum fields. It can preserve ancient radiation from the beginning of the universe. So when we imagine deep space as a silent blank, we are only partly right. It is silent to our ears, but not empty to physics. 11. The universe once expanded faster than the speed of light. This does not mean galaxies flew through space faster than light in the ordinary sense. It means space itself expanded extremely rapidly during a brief early period called cosmic inflation. Physics does not allow objects to locally move through space faster than light, but space itself is allowed to expand. That distinction sounds like a loophole, but it is central to modern cosmology. Inflation helps explain why the universe looks so smooth and nearly flat on enormous scales. The early universe did not just grow. For a tiny fraction of a second, space itself may have stretched with almost unbelievable speed. 12. Light from galaxies is stretched by the expansion of the universe. As space expands, the wavelengths of light traveling through it become longer and redder. This is called cosmological redshift. It is one of the ways astronomers measure how far away galaxies are and how the universe has changed over time. A distant galaxy is not merely far away in space. Its light has been traveling while the universe itself has been expanding beneath it. By the time that light reaches us, it carries the story of the space it crossed. The color has changed because the universe has changed. 13. We can look into the past by looking far away. This sounds like science fiction, but it is one of the most basic truths of astronomy. Light takes time to travel. The moon is seen as it was about 1.3 seconds ago. The sun is seen as it was about 8 minutes ago. Andromeda is seen as it was about 2.5 million years ago. Distant galaxies can be seen as they were billions of years ago. Telescopes are time machines, not because they move us through time, but because the universe delivers old light slowly. Every deep image of space is also an image of history. 14. The Andromeda galaxy is so far away that its light left before modern humans existed, and yet it is one of our nearest major galactic neighbors. Andromeda is about 2.5 million light-years from Earth. That means the soft glow reaching us now began its journey when early human ancestors were walking the planet, long before cities, writing, or astronomy. And yet, in galactic terms, Andromeda is nearby. It is the nearest large spiral galaxy to the Milky Way. This is how strange scale becomes in space. Something can be close and still unimaginably distant. 15. The solar system is moving around the center of the Milky Way at about 15,000 miles per hour. We do not feel this motion because everything around us is moving with it. Earth, the moon, the sun, the planets, and all the objects gravitationally bound to the solar system. But our entire planetary neighborhood is not sitting still. It is orbiting the galactic center at high speed, carried through the Milky Way like a ship moving through a vast stellar ocean. Even when you are lying quietly in bed, Earth is rotating, orbiting the sun, and traveling through the galaxy. 16. One orbit of the sun around the Milky Way takes about 230 million years. This is sometimes called a galactic year. The last time the solar system was roughly in this part of its galactic orbit, dinosaurs were only beginning to dominate Earth. Human civilization has existed for a tiny fraction of one galactic year. Even life itself has experienced only a limited number of these enormous circuits. It is a peaceful but humbling thought. The sun has been circling the galaxy for billions of years, and our entire recorded history is less than a blink in that slow orbit. 17. The Oort cloud may contain hundreds of billions or even trillions of icy bodies. It is not a flat ring like the asteroid belt or Kuiper belt. It is thought to be a vast spherical shell of distant icy debris surrounding the solar system. We have never directly observed the Oort cloud as a complete structure, but its existence is inferred from the behavior of long-period comets that seem to come from all directions. Some comets may spend hundreds of thousands or millions of years falling inward from this distant cloud before briefly visiting the inner solar system. The solar system is much larger than the planets make it look. 18. Voyager 1 entered interstellar space in 2012, but it still has not left the solar system in every sense. That sounds contradictory, but it depends on what boundary you mean. Voyager 1 crossed the heliopause, where the solar wind gives way to the interstellar medium, making it the first human-made object to enter interstellar space. But the Oort cloud, if counted as the outermost gravitational boundary of the solar system, lies far beyond. Voyager will take thousands of years to pass through that distant region. Human engineering has touched interstellar space, but the Sun's outermost influence stretches much farther. 19. The Moon is slowly drifting away from Earth. Lunar laser ranging experiments using reflectors left on the Moon during the Apollo era show that the Moon is moving away at about 1.5 inches, or 3.8 centimeters, per year. That is roughly the rate at which fingernails grow. It is not something we notice in a lifetime, but over millions and billions of years, it matters. The Moon was once closer, Earth once spun faster. Days were once shorter. Our familiar sky is not fixed. It is a slowly changing relationship between two worlds. 20. The Moon helps slow Earth's rotation. The same tidal interactions that push the Moon gradually outward also slow Earth's spin over long timescales. The effect is tiny on human clocks, but real. Earth's days have not always been 24 hours long. In the deep past, days were shorter and the Moon appeared larger in the sky. This is one of those facts that makes the present feel temporary. Even the rhythm of a day, something that feels so basic and stable, is part of a long gravitational negotiation between Earth and the Moon. 21. Mercury, the closest planet to the Sun, can have water ice. That sounds absurd until you remember that Mercury has almost no atmosphere and very strange temperature conditions. Its day side can become extremely hot, but near its poles, some crater floors remain in permanent shadow. Sunlight never reaches them directly. In those cold traps, radar-bright deposits are thought to be water ice, so the planet closest to the Sun may preserve ice in dark polar craters. Space often hides cold in places where your intuition expects only heat. 22. Venus is hotter than Mercury, even though Mercury is closer to the Sun. Venus has the hottest surface of any planet in our solar system because of its thick carbon dioxide atmosphere and intense greenhouse effect. Its clouds are made of sulfuric acid, and its surface pressure is crushing. Mercury is closer to the Sun, but without a thick atmosphere to trap heat, its temperature changes dramatically between day and night. Venus, wrapped in its dense atmosphere, keeps the heat in. The hottest planet is not the nearest one. It is the one with the most suffocating blanket. 23. Titan has rivers, lakes, seas, clouds, and rain, but not made of water. Titan, Saturn's largest moon, is the only place besides Earth known to have stable liquids on its surface. But because Titan is so cold, those liquids are hydrocarbons like methane and ethane. It has a weather cycle that is strangely Earth-like in structure, with clouds, rain, flowing channels, lakes, seas, and evaporation, but the chemistry is alien. On Earth, water falls from the sky. On Titan, methane can rain onto frozen landscapes under a hazy orange atmosphere. It is familiar and unfamiliar at the same time. 24. Titan may also hide a subsurface ocean of liquid water. Beneath the methane lakes and icy crust, evidence suggests Titan may have an underground ocean, likely mixed with salts and ammonia. This means Titan may have two very different kinds of liquid environments: hydrocarbon lakes on the surface and water deep below. It is a world with layered possibilities. On the surface, a cold, organic chemistry unlike Earth's. Beneath it, perhaps a hidden ocean, more recognizable to life as we understand it. Titan is not just a moon. It is a complex planetary world. 25. Europa may have more than twice as much water as all of Earth's oceans combined. Europa is one of Jupiter's moons, and beneath its icy surface, scientists see strong evidence for a global saltwater ocean. The clues include its cracked icy surface, limited cratering, and magnetic field behavior consistent with a conducting salty ocean below. The idea sounds impossible at first, a frozen moon far from the Sun with more water than Earth. But tidal heating from Jupiter's gravity may keep Europa's interior warm enough for liquid water beneath the ice. A moon can be frozen outside and oceanic inside. 26. Uranus spins on its side. Its rotational axis is tilted by almost 98 degrees, making the planet appear to roll around the sun like a ball. This gives Uranus some of the most extreme seasons in the solar system. For long periods, one pole can face the sun, while the other is plunged into darkness. A collision with an Earth-sized object long ago may have caused this strange tilt, though scientists are still studying the details. Uranus is not simply another blue planet. It is a sideways ice giant with a history written into its posture. 27. Jupiter's Great Red Spot is a storm larger than Earth. It is the largest known storm in the solar system, with winds that NASA describes as raging around 500 miles per hour. The storm has been observed for generations, and it has changed size over time, shrinking from much larger historical measurements. Still, the fact remains astonishing. A storm system on Jupiter can be larger than our entire planet. Earth's greatest hurricanes last days or weeks. Jupiter's most famous storm has endured for centuries, moving through an atmosphere with no solid surface to stop it. 28. Jupiter could fit more than 1,000 Earths inside it if it were hollow. This is a scale fact that always sounds exaggerated, but it is real. Jupiter is the largest planet in our solar system, a gas giant so massive that it outweighs all the other planets combined by a large margin. Yet it is still not a star. It never grew massive enough to ignite sustained hydrogen fusion in its core. Jupiter sits in that enormous space between planet and star, a reminder that nature builds objects across a wide spectrum, not in neat human-sized categories. 29. Saturn has a hexagon-shaped jet stream at its north pole. A six-sided storm pattern sounds like something from a fantasy map, but spacecraft have photographed it. Saturn's north polar hexagon was first observed by Voyager and later studied in detail by Cassini. It is a persistent atmospheric structure, not a solid feature, created by patterns in Saturn's winds. The idea of a planet-sized hexagon floating in the clouds of a gas giant feels unreal, but gas giants are not smooth, simple worlds. Their atmospheres can organize themselves into forms that look almost geometric. 30. Plasma makes up almost all of the visible universe. On Earth, we are used to solids, liquids, and gases. Plasma feels unusual because we encounter it mainly in lightning, auroras, neon signs, or specialized technology. But in the visible universe, plasma is everywhere. Stars are made of plasma. The solar wind is plasma. Much of the material between stars and galaxies is ionized. NASA describes plasma as making up 99.9% of the visible universe. So the state of matter that feels rare on Earth is the ordinary state of matter across the cosmos. 31. Stars can sing, though not through space the way sound travels through air. Inside stars, pressure waves move through hot plasma, causing tiny oscillations. Astronomers can detect these vibrations by observing changes in brightness or motion. The field is called astroseismology, and it lets scientists study what stars are made of, how large they are, how old they are, and what is happening inside them. Space itself is too empty to carry ordinary sound to your ear, but stars have internal music. We cannot hear it directly, but we can translate its pattern from light. 32. The sun itself vibrates like a giant resonant object. Scientists study these vibrations through helioseismology, the solar version of seismology. Just as earthquakes reveal Earth's interior, waves in the sun reveal its hidden layers, motions, and structure. To our eyes, the sun is a bright disk. To instruments, it is a moving, pulsing, churning sphere of plasma filled with waves. The star that lights our days also has rhythms beneath its surface. It is not silent because nothing is happening. It is silent because space does not carry its sound to us. 33. A neutron star can pack more mass than the sun into a sphere about the size of a city. Neutron stars form when massive stars die in supernova explosions and their cores collapse. NASA describes them as ultra-dense objects around 12 miles or 20 kilometers across, with up to twice the mass of the Sun squeezed inside. That is difficult to imagine because nothing on Earth is remotely similar. A neutron star is not just dense, it is matter pushed to one of the most extreme observable states in the universe. 34. A teaspoon of neutron star material would weigh about 1 billion tons on Earth. This is one of the classic space facts that sounds fake because no everyday object prepares us for it. The atoms inside a neutron star are crushed until ordinary atomic structure breaks down. Matter becomes packed at nuclear densities. You could not actually scoop neutron star material and bring it to Earth in any normal way. The image is a way to express density, but as a comparison, it is real enough to be breathtaking. A city-sized remnant can outweigh the Sun because space has compressed matter almost beyond comprehension. 35. Magnetars have magnetic fields about 1 trillion times stronger than Earth's magnetosphere. A magnetar is a special kind of neutron star with an extremely powerful magnetic field. These objects are rare, and only a small number are known. Their magnetic fields are so intense that they can produce violent high-energy outbursts and may help explain some fast radio bursts. The numbers sound absurd because Earth's magnetic field already feels important to us. It guides compasses and helps shape auroras. A magnetar's field is in another universe of strength, a force so extreme that ordinary matter nearby would not remain ordinary for long. 36. Some radio bursts from space last only milliseconds but release enormous amounts of energy. Fast radio bursts are brief blasts of radio waves, and for years their origin was one of astronomy's great mysteries. In 2020, a magnetar in our own Milky Way produced a burst that helped show magnetars can create at least some of these events. This does not solve every fast radio burst, especially those from other galaxies, but it gave scientists an important clue. A signal can be short, almost like a cosmic blink, and still carry information from one of the most extreme objects in the universe. 37. Gamma-ray bursts are among the most powerful explosions known. NASA describes them as short-lived outbursts of the highest energy light, able to erupt with 1 quintillion times the luminosity of the Sun. Some are connected to collapsing massive stars. Others are connected to neutron star mergers. They can be visible from across the universe because they release energy on a scale almost impossible to imagine. A gamma-ray burst can happen far away, last only seconds or minutes, and still announce the birth of a black hole or the collision of stellar remnants. 38. We have detected ripples in space-time. Gravitational waves were predicted by Einstein's general relativity, but directly detecting them took more than a century. In 2015, LIGO detected gravitational waves from the merger of 2 black holes. These waves traveled for about 1.3 billion years before reaching Earth, where they changed the lengths of LIGO's detectors by an incredibly tiny amount. The event converted about 3 solar masses into gravitational wave energy. That sounds impossible, but it happened. Space itself can ripple, and we have built instruments sensitive enough to feel those ripples. 39. 2 black holes can merge without producing ordinary light, yet still be heard by gravitational wave detectors. Black holes are dark in the sense that light cannot escape from within their event horizons, but when they spiral together, they shake space-time. That signal carries information about their masses, spins, and final merger. This opened a new kind of astronomy. For most of history, we studied the universe mainly through light. Now we can also study it through gravitational waves. It is as if the universe gained another sense. We are no longer only watching the cosmos. We are listening to its deep vibrations. 40. We have taken an image of a black hole's shadow. In 2019, the Event Horizon Telescope collaboration revealed the first image of a black hole, the supermassive black hole at the center of galaxy M87. The black hole itself is not visible because no light escapes from inside the event horizon. What the image shows is a dark central shadow surrounded by glowing hot gas shaped by extreme gravity. It is not a normal photograph in the everyday sense. It was made by combining data from telescopes around the world. But it is real observational evidence of one of the strangest objects physics allows. 41. The black hole at the center of our own galaxy has about 4 million times the mass of the Sun. It is called Sagittarius A, pronounced A star, and it sits at the center of the Milky Way. Compared with some supermassive black holes, it is actually modest. Some galaxies host black holes with billions of solar masses. But for us, Sagittarius AI is enormous enough. It anchors the dynamic center of the galaxy, surrounded by stars, gas, dust, and high-energy activity. Our galaxy is not just a spiral of stars. It has a massive dark engine at its heart. 42. Almost every large galaxy may have a supermassive black hole at its center. This is one of those facts that sounds like the opening line of cosmic horror, but it is part of modern astrophysics. These black holes can have masses from hundreds of thousands to billions of suns. Scientists are still trying to understand exactly how the largest ones formed, especially because some appeared very early in cosmic history. Galaxies and black holes seem deeply connected. The center of a galaxy is often not empty, but occupied by one of the most extreme gravitational objects in existence. 43. Black holes are not holes in space. They are concentrations of matter packed into very small regions, with gravity so strong that below the event horizon, nothing can escape. The event horizon is not a solid surface like a planet's ground. It is a boundary in space-time. Cross it, and all future paths lead inward. That is part of what makes black holes so strange. They are not tunnels, not cosmic drains, and not empty wells. They are places where mass, gravity, light, and time interact at the limits of our theories. 44. Time runs differently near strong gravity. This is not only a science fiction idea, it follows from general relativity and has been tested in many ways. Clocks in stronger gravitational fields tick more slowly compared with clocks farther away. Near a black hole, the effect becomes extreme. From far away, something falling toward the event horizon can appear increasingly slowed and redshifted. Time is not a universal background ticking the same for everyone. It is part of the physical fabric of the universe, and gravity can stretch it. 45. The Milky Way contains a web of dark matter filaments and structure we cannot see directly. On the largest scales, galaxies do not scatter randomly like dust. They gather along filaments, walls, and clusters, separated by enormous voids. Hubble observations and simulations help map this cosmic web, including the distribution of dark matter. The result looks almost biological, like a network of threads and nodes, but it is gravity, matter, expansion, and time. The universe has a skeleton, and much of that skeleton is invisible. 46. The largest structures in the universe are not stars or galaxies, but networks of galaxies. Individual galaxies are enormous, but they are only pieces of larger patterns. Galaxy clusters gather into superclusters. Superclusters and filaments form the cosmic web. Between them are voids, regions with far fewer galaxies. From close up, space looks filled with isolated lights. From far enough away, those lights trace something like foam or branching veins. The universe is not arranged as a uniform sprinkling of stars. It has architecture on scales so large that our minds struggle to hold them. 47. Some regions of the universe are almost unimaginably empty. Cosmic voids are vast spaces with relatively few galaxies. They are not truly empty because there may still be dark matter, gas, faint galaxies, fields, and radiation, but compared with galaxy-rich regions, they are sparse and quiet. A void can stretch for tens or hundreds of millions of light years. The idea is unsettling but peaceful. Enormous volumes of space where almost nothing bright exists. In the cosmic web, voids are not mistakes. They are part of the pattern, the dark spaces between the threads. 48. The oldest light we can see is not starlight. It is the cosmic microwave background, released before stars and galaxies existed. The first stars had not yet ignited when this light began traveling. It came from the hot early universe itself, after atoms formed and the cosmic fog cleared. That means our deepest direct view is not a galaxy, not a star, not a planet, but a background glow from the universe's first transparent age. Astronomy often feels like looking outward, but with the cosmic microwave background, looking outward becomes looking backward to before the first starlight. 49. The first stars may have been far more massive and brighter than the Sun. NASA notes that the universe's first stars may have been tens to hundreds of times more massive than our Sun and millions of times brighter. These early stars formed from mostly hydrogen and helium before later generations enriched the universe with heavier elements. They burned hot and died quickly, seeding space with the ingredients needed for planets and life. In a sense, the first stars were not merely lights in the darkness. They were chemical factories that made the later universe possible. 50. The iron in your blood was made in stars or stellar explosions. The calcium in your bones, the oxygen you breathe, the carbon in your body, and the heavier elements around you were forged through cosmic processes. The early universe began mainly with hydrogen, helium, and a little lithium. Heavier elements came later through stars, supernovae, and related events. This fact is often summarized by saying we are made of stardust. It sounds poetic, but it is scientifically grounded. The atoms in your body have a cosmic history older than Earth. 51. Some of the gold in the universe may come from neutron star collisions or extreme magnetar-related events. Heavy elements require extreme conditions to form. Neutron star mergers are known to create heavy elements, and NASA studies also explore how magnetars and other high-energy events may contribute. Gold is not simply a shiny metal. It is evidence of violent cosmic history. A ring, a coin, or a tiny flake of gold carries the memory of conditions more extreme than the center of most stars. Beauty on Earth can be the quiet remnant of catastrophe in space. 52. There are planets around dead stars. Some of the first confirmed exoplanets were found orbiting a pulsar, a rapidly spinning neutron star. That is strange because pulsars are remnants of supernova explosions, environments that seem hostile to planets. Yet planets can exist there, detected through tiny changes in the timing of the pulsar's signals. A dead star can become a clock, and a planet can be discovered because it disturbs the clock slightly. Planetary systems are not limited to peaceful sun-like stars. They can survive or reform in places that feel almost impossible. 53. Some planets may be remnants of former stars. Certain dense planetary mass companions around pulsars may be stripped cores, what remains after a star lost most of its material. These objects blur the line between planet and stellar remnant. A planet is not always born as a normal planet from a dusty disk. Sometimes an object can become planet-like after a much more violent history. Space categories are useful, but nature often ignores our clean definitions. Some worlds are not simply made, they are leftovers. 54. Some exoplanets are lighter than cotton candy by average density. These are often called superpuff planets. They can have very large radii, but surprisingly low masses, making their average densities extremely low. They are not literally made of cotton candy, of course. They are planets with extended atmospheres, often rich in hydrogen and helium, and sometimes obscured by haze. But the comparison helps capture how strange they are. A planet can look large and still be airy, inflated, and difficult to classify. Size alone does not tell the full story. 55. Some exoplanet skies may contain clouds made of minerals. On Earth, clouds are mostly water droplets or ice crystals. On hot exoplanets, conditions can allow clouds of silicates, quartz, iron, or other rocky materials. Webb has detected evidence for tiny quartz crystals in the clouds of WASP-17b. This is one of the strangest shifts in imagination. Rock, something we think of as ground, can become sky under the right temperatures and pressures. On alien worlds, geology and weather can merge. 56. Some exoplanets may rain metal. WASP-76b is famous for the idea that iron may vaporize on its hot day side, then condense on the cooler night side. The planet is tidally locked, so one side always faces the star while the other remains in darkness. That creates a permanent temperature contrast. Winds can carry vaporized iron from day to night, where it may condense and fall. This does not mean a gentle shower of coins. It means a brutal atmospheric cycle of vaporized metal. Still, as a fact, it feels like a line from a dream. 57. Some planets are so close to their stars that their atmospheres are escaping into space. Strong radiation can heat the upper atmosphere until gas flows away. Some close-in planets trail material like giant invisible comets. Over time, atmospheric escape can change what kind of planet remains. A small gas-rich world may lose its envelope and become a rocky core. A giant planet may slowly erode. Planets are not static objects. They can be stripped, inflated, migrated, darkened, and transformed by their stars. 58. Some planets are darker than coal. TRES-2b is often described as one of the darkest known exoplanets, reflecting very little of the light that hits it. It is a gas giant close to its star, but its atmosphere absorbs much of the incoming light instead of reflecting it brightly like Jupiter's clouds. It may glow faintly from heat, but visually it would be extremely dark. The fact sounds impossible because we imagine planets lit by their stars. But a planet's brightness depends on clouds, chemistry, temperature, and albedo. A world can orbit a star and still appear almost black. 59. A world can be blue for deadly reasons. Earth is blue because of oceans, atmosphere, and light scattering. HD 189733b is blue because of a hot alien atmosphere, possibly involving silicate particles. This matters because color can mislead us. A blue dot is not always a living world. A red world is not always Mars-like. A white world is not always icy. When astronomers study exoplanets, they cannot rely on appearances alone. They need spectra, mass, radius, orbit, atmosphere, and context. Space is full of beautiful disguises. 60. Some worlds could have oceans under ice without sunlight reaching them. Europa is the classic example in our solar system, but the idea extends beyond it. Internal heat, tidal forces, and insulating ice can make liquid water possible far from the traditional warmth of a star. This changes how we think about habitability. Life, if it exists elsewhere, may not always live under a blue sky on the surface of an Earth-like planet. It may live in darkness beneath ice, around chemical energy sources, hidden from starlight. 61. The habitable zone does not guarantee habitability. A planet in the right orbital zone may still be uninhabitable if its atmosphere is too thick, too thin, toxic, missing, or unstable. Venus is a useful warning from our own solar system. It receives less sunlight than Mercury, yet its dense carbon dioxide atmosphere creates extreme surface heat. For exoplanets, being in the habitable zone only means liquid water could be possible under the right conditions. It is not a promise, it is a question worth investigating. 62. Some stars are so small and dim that planets can orbit close to them and still receive moderate warmth. Red dwarf stars are much cooler than the Sun, so their habitable zones are much closer in. A planet there may have a short year and still receive a reasonable amount of energy, but close orbits create other complications, such as tidal locking and stellar flares. A world around a red dwarf might have a permanent day side and night side, or it might struggle to keep an atmosphere. Habitability is never one simple number. It is a whole planetary story. 63. The James Webb Space Telescope can study the air of planets it will never visit. When an exoplanet passes in front of its star, a tiny amount of starlight filters through the planet's atmosphere. Molecules in that atmosphere absorb specific wavelengths, leaving fingerprints in the light. Webb can read some of those fingerprints. It has detected molecules such as carbon dioxide, methane, water vapor, and sulfur dioxide in exoplanet atmospheres. That means we can learn about alien skies from across light years, not by going there, but by studying the missing colors in starlight. 64. K2-18b may have conditions consistent with a Hycean world, but scientists are still debating what it really is. Webb detected methane and carbon dioxide in its atmosphere, and the results support the hypothesis that it might have a hydrogen-rich atmosphere and a water ocean-covered surface. But NASA is careful. This does not prove the planet supports life. It is larger than Earth, unlike anything in our solar system, and its nature remains debated. That uncertainty is part of the beauty. Sometimes the most exciting facts are not final answers, but carefully measured possibilities. 65. Spacecraft can discover oceans without seeing them directly. Europa's suspected ocean comes from surface geology, magnetic field clues, and the behavior of ice. Titan's hidden water ocean is inferred from gravity measurements and probe data. Enceladus reveals itself through plumes of water, vapor, and ice grains. In planetary science, hidden oceans do not need to sparkle under sunlight to be studied. They can be detected through cracks, fields, plumes, chemistry, and gravity. A world can keep its ocean buried and still leave clues. 66. The Sun's influence forms a bubble around the solar system. This bubble is called the heliosphere, created by the solar wind flowing outward from the Sun. It surrounds the planets and pushes against the interstellar medium. Voyager 1 and Voyager 2 crossed the heliopause, the boundary where this solar influence gives way to interstellar space. It is strange to realize that we live inside the extended atmosphere of a star. The Sun is not only a glowing object in the sky,